You know, it's amazing, this job. You know, we did that Radiomobile CB202, which is as good as it gets. So the next day, Thursday, we opened up the repair box, and the next radio is a Cybernet Beta 2000, which of course is the same thing. I don't know whether all the... Didn't think you had the clear and speech processor position on the other one. Anyway, unbelievable. I wouldn't have done consecutive repairs like this, but I realised that it can be interesting for people just to see the repairs. Originally, we only ever planned to do one video to each type of radio, but people say, "Oh, you haven't done a such and such for ages," you know. So obviously, they like seeing the same sets time and time again because they are all different. So I wonder what grease is with this one. I mean, it's not in the same condition, is it, than yesterday's. He's even got a dent, which for an expensive radio you wouldn't have done. The screwdriver's gone onto the floor. I used to work with a chap by the name of Bob, and he used to refer to the floor as the dog shelf. I think we'll take that off and pack it separately. Will this be a radio that I don't need to switch the soldering iron on for? I can see the VCO can's been adjusted previously. But yesterday's we'd got trouble with that capacitor, not so on this one. I can't see any... as a quick scan round, I cannot see any broken cores, and I can't see any bulging capacitors, and I can't see any dodginess. So and we've still got the power switch intact at the back, which is fantastic. Now the other customer's set's not gone back yet. I put it in bubble wrap and in the top of their box, but I've still got their power lead on my bench, so we will use their power lead, because this one came with a cigarette lighter power lead, and that's a bit of a pain. So make sure that's in the normal position. I can't even read that. Change his glasses. Yeah, normal's that up position. So once again using our mic, so we don't really want customers' mics here, otherwise we've got to dismantle them, put them through the dishwasher, and it's an added expense, because I tell you what, we would be charging £3 to do that. Right, let's connect it to the instruments, and the best thing to do is to write down how it's working right now. Doesn't matter when it's our set, but it might matter when it's a customer's set. So switch on the power supply, switch on the radio. Oh, it's rotary on this, it was push on the other one. See, they are different. Channel 20. Make sure that's off. Halfway, that's a full. Okay, switch on picture in picture, and you can see the meter. Right. Okay, so the radio is doing 3 watts. So that's 5, 4, 3. If we put it on a 3 watt scale, we have full scale deflection. It's probably doing about 3.1. So I'll give it the benefit of that. Power 3.1 watt. The frequency it's on at the moment. Just changed cameras. Should be 2779125. Here's another one that's high. And like yesterday, I may as well correct that here and now. Actually, that capacitor doesn't look brilliant. Anyway, we'll see how the radio goes. There we are, 25 toggling 6, that will do nicely. So that's done. Audio, transmitted audio. Wallow. 1.9 kilohertz, that needs to come up. So on receive, just need to plug the instruments in. I think it was that one, but I'm bound to be wrong. No, it's coming through. Right. That sounds pretty distorted. Let's go up to the Cybernet meter. So 20 dB Cybernet, 12 dB Cybernet, 10 dB Cybernet. Might be able to change scales. It said 2 on that scale. Yeah, it's 2.1. 2.1 microvolts. So on for 12 dB, (0.41 microvolts, which is excellent. For 10 dB, 0.35 microvolts. So again, the receiver works quite well, but it does sound a bit distorted to me. Right, so with that, we'll get on with doing the VCO. Out of interest, we'll see how many Zetagi watts that 3 real watts are. Look, it's 5. I had a comment about from an American about radios being 5 watts in their country. No, they're not. It's 5 watts input. In America, a lot of CB radios are sold on input power and not output power. And 5 watts input is often about 3.5 output, so there's no difference. It's expressed in a different way because of the way the rules are. Ooh, it's 5 watts and yours is 4. No. Okay, so we haven't got a missing link today. I don't think I've seen that before. So we'll put our earth onto there. And resistor 4. Top end. It's got all wax there. So we want channel 40. Got 3.5, which is it's supposed to be 4, isn't it? That's receive, and on transmit 1.8. Aha! So that needs to be altered. While we're at it, I may as well put that onto there. So again, with this radio is in danger of channels dropping out. Let's see what happens on channel 1. Yeah, 0.8. In certain weather conditions, the lower channels would have dropped off. So we'll start with transmit, and we're back on channel 40, and I need to adjust the trimmer back there for 4. I think these is again dirty, so we're just going to waggle that round a bit and start again. It actually won't set up, and I'm just going to change that capacitor just as a matter of course. It may be just the way it is, or that capacitor might be not helping. Okay, so having changed that capacitor, let's see whether we can set this up any better. And I'm getting no reading. Why is that? Is my earth off? 3.4. I mean, there is a tolerance between sets, but we're nearly there, aren't we? I mean, 3.53 is the highest this is wanting to go. So let's see whether we can set receive, which is also 4. My goodness, that's stiff. So we'll have that at the top end. Let's see where we are now with transmit 3.2. See if we can change that. Well, it's over 3. It's in lock. And let's see where receive is once again. Still 4. Let's see where channel 1 is. 1.6. It really needs to be 1.8. It's just lower than normal. It's I can't see there's a problem. It is in lock. Now that capacitor I took out is a 1 microfarad. It's probably okay, but the fact it's starting to recede at the top, I just wonder if it's been hot, and it has made a slight difference. Yeah, it's starting to drop, that one, so I was right to change it. So if you remember, on channel 1 it was 0.8, so on channel 1 now is 2.14 and 1.67. So it's not exactly where it should be, but I think that's solidly in lock. Put that away. It's the old, we strive to meet and exceed specifications. Okay, so we'll go on to transmit power, and at the moment it's just doing under 3 watts because it's been warmed up. Oh, oh yeah, we are on channel 20. I thought we were still on channel 40. So no improvement there. Try and get that between the wiring. Slight improvement there. No improvement there. Move over to these and it's maximum. That's 3.4. Oh, this one is broken. It didn't look it from the top, but it is. So that's peaked those two, but the broken one we'll have to deal with by unsoldering it and hoping we can find another scrap Fidelity 1000. Right, we're going to have to hold on transmit because I haven't got a spare core. We've got no more scrap sets we can pinch one off. So I'm going to just have a look in another of our stores departments later on in the day. What we'll do is we'll proceed with receive on this radio instead. Switch it back on. Ah, we can't do that because receive passes through that coil, which I didn't expect. Okay, so job's abandoned until I can find another core. Okay, so fast forwarding several hours. We're now at 3 o'clock in the afternoon, and I've been to the storage facility that we have, and I've found a chassis which caused me to drop something on the floor. Which probably, it's not a Harvard good buddy. I wonder if it's one of the Alba CBM5s or the Harvard equivalent. Anyway, the core out of that coil is now ready to go in, and I've put that, soldered the coil back into the radio, so we'll carry on with transmit. So switch on the radio, and there we go with 3 watts or whatever it is, 3.3, yes. So that's as far as we'd got. We'll peak that. So there we are, we're now at 4.4. Then we'll peak that one. Just about 4.4. Just check they're all peaked, because they are interactive. There we are. So we need to turn this clockwise for 4.4, which is there. This one anti-clockwise for 4. And that should more or less give us the full 4 watts throughout the 40 channels. So we're on channel 40, about 3.95. Channel 1, about 4.05. So this is about as balanced as you usually get. It's a generous for that. Good. Well, that's sorted the power problem out with that. And you see how the screwdriver expert had generated 70 target watts, but that means it'll be all over the place when we get the spectrum analyzer onto that. Shall I do that now? No, we'll do I'll try and get down the radio, and then it's so I can do that off screen. You've seen me do that enough times, getting rid of the harmonics. Let's have a look at the deviation. So we need the AGC to centre position, and we need the deviation increasing. Probably about there. Let's try that. Wallow. spot on. 2.2, an absolute maximum there of 2.5. So that was straightforward. Now then, let's see if we can set the power meter. It's probably, we have to do this in low power on the sets with the LED displays. So we know the radio is doing 4 watts because it says so. So I'll now reduce the power to 0.4. Just slightly high. We usually find that these controls are dirty, so I'll just spray that. Give it a quick twaddle round and reset that for 0.4. Slightly over, that will do. Now then, on transmit, we're supposed to have 1 bar. So we need to adjust the power meter to 1 bar. Then when we go back on full power, the radio is still doing 4 watts, and we've got all of the bars showing. So that's that done. Okay, so that's finished the transmit, apart from when we look at it with the spectrum analyzer. So moving over to receive. Here we go with receive. So we'll put the camera onto the oscilloscope. And we'll see if we need to set the detector. So as ever, it's maximum smoke, as John used to say at Nottingham, where I worked once. Wow, that was miles out. So we'd have had quiet receive. And over to the cyanide meter. So we'll drop the signal on the signal generator, and knocks it off frequency at the same time. Now we're back on frequency. So we want to drop this till we get about 4 decibels. Massive improvement, even though it worked well. I don't know why the screwdriver experts fiddle with these, because, you know, you can go and get a signal generator for a tenner, an old-fashioned one which does AM only, and you can tune up an FM radio on an AM signal generator apart from the detector. I've done this on my series of doing them on a budget, so amazes me. I'll just put the signal up a bit for these. Oh yes. Then I can't even see the other one. I bet that's not being fiddled with, it's right under the wiring. You know what? It's absolutely spot on. So the one hidden under the wiring they'd not noticed. Nifty. There we go. So now let's look at the cyanide. So we'll start with 20. And I've got well, it's unbelievable. That's now 0.45 from 2.1. 12 is now 0.26, and 10 is 0.23. So this is one of those exceptionally performing radios once again. What a difference! And I thought it was fantastic as it was, apart from the 20. So the IF was out on causing the 21, but the front end was out as well, so great. So we need to do the S meter. So we'll put S9 on the signal generator, that's 100 microvolts. And I may as well put that on. And camera 6. So we're showing the test instruments, which are now at 100 microvolts. So we should have all 4 just lit. So we'll just adjust that. We will just adjust that. That goes well, doesn't it? Just the preset just there. So it's just on 4. You see, I've turned it till it's 3 and just gone back till it's 4. Now, when we adjust the signal generator, if we turn it down, the signal goes down and the signal goes up as we go up. So finally, we need to set the squelch. So I'm going to park the signal generator at 30 microvolts and making sure the RF gain, put the tone to center, squelch to full. Now it should come in at 100 microvolts. It doesn't. So we need to adjust the preset until it does. So it's just there. Now turn it down to 30, it's gone. 100, it's back. That's set right. So now we'll park the signal generator at 0.3 of a microvolt and switch the signal generator off. Turn the squelch to minimum and threshold. There's threshold. Switch the signal generator back on. And it's come straight in, which is excellent. No, threshold's too fine. I'll have to reset threshold. Start again. So it's coming in at 0.9, leaving it 0.85. So that'll be sensitive enough. So that's set. Channel 9 switch does that. Dimmer does that. And we'll check the speech processor when we do the on-the-air test later. So that is the set finished. We'll just look at it on the spectrum analyzer. Press auto on there and select camera 5. And there we have it, 2779125. Let's look at the harmonics. There's our harmonic. Could do with going minus 58, could do with being a bit lower. So let's hope that if I turn this one without reducing the power, sometimes the coil stretch has been inside, and I don't think so on this occasion. Anyway, we look to be in spec there, but I'll just verify that. Just put a crocodile clip lead onto earth. And we will do frequency 27,79125 megs. There we are. And I'll unplug that. So we've got that signal there, minus 27 dBm, and our naughty one is there. That's it. Just get the measuring thing on there. About minus 64 dBm. So there we go. That's about as good as we're going to get. Let's see how many Zetagi watts it's doing. Ah, 4.5 Zetagi watts. So what does that tell you? Because we started off at 7, didn't we? And it was 3 on the meter. So now it's 3.6 on the meter, on the Marconi meter, and it's only just over 4 on here. And that tells us that the radio isn't chucking out piles of rubbish. A lot of these people turn up radios, but in actual fact turn them down. It's good fun. So I'll come back to that, and I think the job's a good one, as they say. Right, so we'll put the lids on it and let's see what happens. 19 Roger. He's over loud, so he's over deviating. Right, so we'll see how that works on the air test, and I'm sure that's going to be very good because it's working exceptionally well. 4 full watts and very good receive. So that's another one spot on. Thank you for watching the Cybernet Beta 3000 from 1981.